Howdy folks, Mr. Reed here, and welcome to One More Question. So for today, we're going to be taking a look at horizontal and vertical stretches, another type of transformation. So I'm going to do just these two types of stretches individually, and I'm not going to include reflections yet. So if you want to see the reflections thing, you want to pop over to my medium video. This one's going to be mild and only focus on these stretches. So if that's what you're here for, let's get to it. All right, so before I answer the two questions that are up above, I want to get kind of a general idea of what these stretches look like, which one's which, and what kind of effect they're going to have on the function. So I'm going to generally write down that g of x is equal to a onto f of x. So that a on the front of that function is a coefficient, and it's going to apply a particular sort of stretch. And we're going to see in just a moment what kind of stretch that is and how we can kind of tell that that's why, or what's going to happen in this particular case. So let's think about it. F of x is our original y value. If we just take that y value and multiply it by a number, that's just a multiplicative factor, a coefficient. So what it's going to do is it would be, for instance, for an a value of 2, it's going to double whatever's currently there. If we had an a value of 10, it's going to multiply it by 10. So it just takes your old y value and multiplies it simply by whatever the a value is. So that is going to take all the points and stretch them away from the x-axis. So anything that used to be 2 units away, if you stretched it by a factor of 3, would be 2 times 3 is 6, so it would be 3 times higher than it was before when you're comparing it to the x-axis. One of the important things to note is because of the way we're setting this up, we're always scaling things considering the axes. So if you had, for instance, a y value of 0, it doesn't matter what you're going to multiply it by, it's going to stay right there on the axis. And because of that, that ends up being our line of, not necessarily symmetry in this point, but it's kind of like your where you're going to have invariant points. Things are not going to move away from that axis. I'm going to get more into invariant points a little bit later, but for the time being, just know that it is the x and y axes that are going to be the important, no stretchy places, depending on whether you're doing a vertical or horizontal stretch. So in this particular case, what this a parameter is controlling is the vertical stretch of this particular function. So vertical stretch, great. It's just going to simply multiply it by whatever number you've placed in the a value, and that is it. Good. So that's generally what that's going to do. Now, if I were to instead say that g of x was equal to f onto b bx, we now have another coefficient, but this coefficient is taking place inside of the argument rather than outside of the argument. And because of that, what's going to happen in this particular case is different than the first time. This one's a little harder to reason through. Now, we are going to see that it is the horizontal stretch, but the way that it behaves is a little bit wonky. So let's think about this for a moment. If I have a 2 for the b value, so I'm just going to write that down even so we don't forget that. So if I say my b value is 2, what's it going to do? Well, actually, it's kind of funny. My p of x up there is a 2. You know what? I'm going to switch that up. Just let's say you have a b value of 4. I don't know why, just to make sure that I have something to do after we're done talking about it. So if we had a b value of 4, what happens is that the function, instead of seeing the original x value, for instance, let's say x was 1, the function is not going to see the 1. We pass it a 1, but it gets multiplied by a 4 before the function ever does anything to it. So the function sees something that's out at a value of 4 when we passed it a 1. So it sees the 4 when we give it a 1. And so what happens is the 1 acts like it was a 4. So that 4 value comes all the way back and acts at 1 instead. But if we had a value at 5, 6, 7, 8, that would also, sorry, if we pass it a 2, my apologies, that's not very clear. Pass it a 2, then we would multiply by 4. It would act like an 8, but that 8 would get placed all the way back at 2 because that's what we passed it. We gave it an x value of 2. So the x value is 2. It just acts like an 8 when the function is doing its thing because of that stretch that's taking place. So we've taken the thing that used to be at 4 and squeezed it in to be a 1, and the thing that used to be at 8 and squeezed it in to be a 2. As you can see, that's going to make the function quite a bit scrunchier than it was before. So what that means is we are actually stretching in a smaller type version. So we call them stretches still. You could say compression if you wanted to. The stretch factor is actually, what would it be? So think about that for a moment. It's a 4, but it's not stretching by a factor of 4 because that would be 4 times larger out this way. What is it actually? Stretching by a factor not of 4, but of compressing by a factor of 4, which if you try to multiply and you want something to be only a quarter of what it used to be, then we would say that that's a stretch factor of a quarter. So oddly enough, this b value of 4 means a stretch of 1 over 4. Now that's very interesting. Is that always going to work that way? If we make something and it acts like it used to be 3 times bigger, but we pull it in, is that going to be a stretch of a third? Yeah. What would it be if we were to use other numbers? Well, it ends up that it actually always works on something we call the reciprocal. So if it was 4 for your b value, it's going to be a 1/4 stretch. If it is a 10, it's going to be a 1/10 stretch. If it's a 3/2, it's going to be a 2/3 stretch. So it always works on the reciprocal, which is pretty interesting. So we have to be a little bit careful. Last time the A was the vertical stretch. B is the parameter that is associated with the vertical stretch, but it's actually 1 over B horizontal. It's actually 1 over B that is the horizontal stretch factor. So it's a little bit tricky, a little bit dicey, but if you kind of get into a groove with it, it's going to make sense. So let's do a couple practice rounds by looking at the questions above. And then if you kind of want some more variety to feed on, then you can go over to the Medium video and see what's going on there. All right, so let's go ahead and write this first one down. So we have m of x is equal to 5 onto f of x. So first of all, is this in the A or the B position? Well, it's out in front of the function as a coefficient. So this is the A position. That A position is a vertical stretch. Vertical stretches act very, very straightforward. So it's just going to take all the y values and multiply them by 5 in this case. So this is a vertical stretch of 5. Factor 5. It depends on how clear you want to be with your English there. I'm just going to say that the vertical stretch is 5, or it's a vertical stretch of 5. Now, next up, p of x. This is the tricky one. So it is going to be f onto 2x. So this is in the B position. And the biggest thing that you can do for yourself is memorize the location of these parameters so that you just beyond the shadow of a doubt, you can say, oh, that's a vertical translation. That's a horizontal translation. That's a vertical stretch. That's a horizontal stretch. Once you can do that without having to put any thought into it, it will be much easier to do the rest of these questions. There is some understanding, obviously, to it because we can walk ourselves through it and think about it every time. But I'm a big supporter in math of getting some of the baseline things down to a memory kind of situation. So for instance, if you're doing a lot of work with 1-digit multiplication, it's a pain in the butt to pull out a calculator every time you are going to need one of these numbers because you can train yourself, even if you aren't that way right now, to be faster than it is to pick up your calculator, push the buttons, and press equals. So if you want to know that 4 times 7 is 28, you just do it, and then you write it down. Saves you time, saves you effort, and it doesn't distract you from what you're currently doing. That's a ramble for another time, though. So let's get back to the question. P of x is equal to f onto 2x. We said that that's the b value, but the b value is not the horizontal stretch. The b value is the reciprocal of the horizontal stretch. So in this case, we're actually going to have a horizontal stretch not of 2, but of 1/2. So let's write that down, horizontal stretch of 1/2. So as you can see, we got vertical and horizontal stretches to deal with now. If you're looking again for some reflections, I'm going to do those in my medium video coming up. It was nice having you around. If you found it helpful, like, subscribe, and thank you very much. Take care, folks.